In this video, I'll show you how to build your own artificial intelligence application that utilizes RAG, Retrieval Augmented Generation, without writing a single line of code and in just a few minutes. Now, the way we'll do that is using something called Langflow. Now, I have it open on my screen. You can see what the finished application will look like, and notice that it's all visual. We can pull in here some pre-built components, we can connect them in a really intuitive way, and then we can run the entire application right from this platform. So let me run it for you, give you a quick demo, and then I'll show you exactly how we build this. So the demo is running, and just to give you a bit of information, this app is going to represent a chatbot for something like a restaurant. Now, really, it could work in any context, but the idea is we'll have something like a PDF here that has some commonly answered questions. So if you're a restaurant or some store, you probably get asked the same thing all the time. When are you open? Where are you located? Do you accept credit cards, cash, whatever? So that's inside of some PDF document. We're going to pass that to the LLM, and then the LLM will be able to answer questions based on that document, and it's also going to store our conversation history so it will remember what we asked last. So let's ask it a question, and notice that I can even put in my name here so that we can see who's who's asking the question. So I'll say, what time are you open, and do I need a reservation, ? Let's see what it says, even though I spelled that incorrectly. So there you go, we got a response. We're open from 11 a.m. to 10 p.m., blah, blah, blah. And while reservations are recommended, we always try to accommodate walk-ins. Let's ask it something else. Let's say, can you tell me about the specials and the menu, ? And there we are, we have a reply here that's giving us some information from the PDF. So variety of vegetarian and vegan dishes. They have a kids menu and there's specials based on the chef's selection. Now, if I go back to the PDF, you can see that if we look here at our specials, for example, it says, yes, we feature specials that include dishes and chef's selection. Do you have a children's menu? Yes, we have a children's menu. Do you accommodate food options, etc.? It kind of gave us all of those different responses and combined them together. So I know it seems simple, but this is something you can really extend and make quite cool. So let's have a look now at how we build this. Okay, so to get started here, we are going to need to install Langflow. Don't worry, it's free. It runs locally on our computer. And we can actually install it using pip, so long as we have Python version 3.10 or above. Now, once we do that, we're actually going to create a VectorStore database using something called AstraDB from the company DataStax. Now, DataStax is actually the sponsor of this video. Don't worry, they're free. You don't need to pay for them. And they've actually teamed up with Langflow just to make this that much better. Once we do that, we're then going to use OpenAI. So we're going to create an OpenAI API key, and we're going to use that to connect to it so that we can have a really powerful LLM. But if you don't want to use OpenAI, you can use really any model that you want. And you'll see in Langflow that you can connect to a bunch of different ones. So let's go through the first step here, which is installing Langflow. To do that, we're going to copy this command from the documentation, which I'll link in the description, to install the pre-release of Langflow. So we'll go back to VS Code. We'll open up some kind of terminal. In this case, I've just created a new folder. This is where I'm going to have my PDF file. Now, we'll talk about the PDF in 1 second, but for now, let's paste this command in. And if you are on Mac or Linux, it's going to be pip3 install langflow --pre --force --install. And if you're on Windows, it's just going to be pip. Okay, so we'll run that command. I've already got it installed, so I'm not going to do that. It will take a few minutes to run because there are quite a lot of packages that need to be installed. And then what we can do is run the command in our terminal, which is langflow run. When we do that, it should start Langflow on localhost and then give us a browser window where we can start creating our flows. All right, so after you wait a second, you should get some kind of output starting Langflow, whatever the version is, and then it will actually open it at this address. So I've got it open here in my browser. You're not going to see any flows because you haven't created any yet, but in my case, I've created a few, so they're here. So now what we can do is just press on new project here and we can make a new flow. Now you can work off of a template or you can just click blank flow, which is what we're going to do for now. Now, the way these flows are actually stored is with JSON. So what you're able to do is import and export the flows with a simple JSON document. And I'll actually leave a link to a GitHub repository in the description that will have the JSON for the flow we're about to build, as well as the PDF document and any other information that you need in case you just want to go right into the finished product and not actually build it out yourself. Anyways, we're now inside of a flow and we can start building out our application. But I do want to mention that we do want to get access to some kind of PDF that we're going to be providing to the app. So in my case, I have this restaurant Q&A. I'll leave this in the GitHub repo in case you just want to download this one, but you can also make your own, or you could just get a PDF you already have and you can feed that into the app. But just make sure you have some kind of PDF ready and accessible because we are going to need that as we build out this flow. Okay, so let's start building the flow here and kind of go through all the different components, see how to connect them, and build this application. So I'm just going to grab a few components from the sidebar here and bring them in, and we'll start building out this app and kind of talk through it as we go. So I'm going to go into inputs, and notice that you can also just search for stuff up here as well. So for inputs, I'm going to grab a text input, I'm going to grab a prompt, and I'm also going to grab a chat input. Now, let's zoom out a little bit so that we can see all of these. And if you kind of hover over them or you look at them, it tells you exactly what the component is meant for. So what I want to do is I want to get some text input, which is the user's name. Now, this is how we'll understand which user is asking which questions and store that in some kind of chat memory. So for the text input here, I can actually change the name of it. So I'm just going to call that name by clicking on edit. And then for the value, this will be something the user is expected to input. So we don't need to actually put anything here. Now what we'll do is we'll take that and we'll pass that as the sender name. So notice I'm taking the output here, which is whatever they type in, and then that's going to be the sender name into my chat input. Now the chat input is going to be the question that the user types. So they can just type whatever they want here. I'll show you how we run that in 1 second. And then we're going to take that and we're going to pass that into our prompt. Now the prompt here is kind of like a prompt template where we can actually write out a few different variables that we want it to accept. And then we can kind of structure how we want to ask the LLM the question. So what I'll actually do is I'll just click on this link here and I'll delete it because I actually don't want to do that. I'm going to click on template and I'm going to write a simple template and I can embed some prompt variables using my curly braces. So I can say something like, hey, answer the user's question based on the following context. And then I can say the context is this, and I can pass inside of here context. And now that's going to be a prompt variable that this can accept. Next, we're going to say the user's question is this, and then this will be the question. And then we'll have the message history as well. We'll say, and this is the message history. And we'll say that that is history. And we can adjust this if we want to make it better, but let's say, hey, answer the question based on the following context. We'll say context, message history, question. Okay, looks good to me. Let's check that, and then notice these variables now appear here in our prompt, and I can pass them in. So for the chat input, that's going to be this, so that'll go as the question. And then for the context, we need to provide that. That's going to be from our RAG, Retrieval Augmented Generation. We're going to use a VectorStore database for that. And then the history is going to come from our chat history. So how do we do that? Well, let's bring in our history here. I believe it's message history that we're using, or actually, it's going to be memory, sorry. We're going to have chat memory. So this retrieves stored chat messages with a specific session ID, and the session ID is going to be the name of the user that's interacting with the model. So we're going to take the name and we're going to pass that as the session ID. So we'll link that up right here. And the idea is whenever we change the name, then it will change the memory that we're using. So if we were talking as Tim and then we change it to Sarah, well, then we get the appropriate memory that the user was typing in before. So it kind of remembers who's saying what. That's the idea here. So we're going to take that, and that's going to be our history. And now that we have that, we can actually pass that to an LLM, and then we can pass that to some chat output, and we can test this before we actually implement the RAG component, which we'll do in a second. Okay, so how do we do that? Well, we need to pass this to an LLM. So actually, if we go to models here, you can see there's a bunch of different models that we can use. Now, I'm going to use OpenAI just because that's the simplest for this tutorial, but you can use Ollama, you can use VectorAI, Hugging Face API. There's a bunch of free versions here, and one version you could use is Ollama. You just need to set that up locally, and then you can run your own local LLM. Again, in our case, we use OpenAI, but you can literally just swap this LLM with any LLM on the left side here that you want to use. Okay, so what we'll do is we'll take the text and we'll pass that as the input here to the LLM. Now what we need to do is we need to get an OpenAI API key. So let's do that, and then we'll move on to the next step. So in order to get this API key, we do need an account with ChatGPT or with OpenAI. The URL is platform.openai.com/API-keys. Now they've changed this recently where you do actually need to fund the account. So you will need to put like $1 or $2 into the account to be able to use this. Again, if you don't want to use this, you can use any other LLM or API that you want, but OpenAI right now is really just the simplest way to do this. So you need to go to API keys and then create a new secret key and then copy that key. So we'll make a new key here. I'm just going to call this tutorial like that. And then you can give it scopes, but in my case, I'm just going to give it access to everything. It's going to give me some key that I will delete afterwards. Let me copy that, and then we can utilize that key. Now, just to show you here, if you want to see if you're able to actually use this or not, you can go into usage, and it's going to show you how much usage you have. So I've used this a little bit today, and then you can click on increase limit. Now, when you click on increase limit, it's going to bring you to this page right here. You'll have the ability to set a monthly budget, and you can kind of go through all of this stuff here. And then you also have the ability to buy credits and to fund the account. So what I can do is go to buy credits here. And when I go to buy credits, what I can do is I can fund the account with a certain amount of money. In my case, I just put in $5, and you can do that from your credit card balance. You can have it auto recharge, etc. They've changed a little bit of how this works, but if you're getting an error saying that you've reached your quota, it's because you do need to fund the account with a little bit of money for it to actually work properly. If you guys know another way to get around that, that's great. But in my case, that's what I had to do. Okay, so now that we have the API key, I'm going to go and I'm going to paste my API key here into the OpenAPI key or OpenAI API key. And what I can actually do if I want is I can make a new variable. I've had some variables here before, but I'm going to make a new one. I'm going to call this OpenAI key new. And then I'm going to paste the value here, and I'm going to make this of type credential. This is automatically going to be encrypted, and then I can just utilize that variable. So I'm going to go with that here in case I need to use this later on in my program. Okay, so now that we have that, we're passing the prompt to the LLM. Now we need to take the output from the LLM and actually display that to the user. So to do that, we're going to go to outputs, and you see that we have a chat output. Now this will display a chat message in the interactive panel. So we'll just take the text and we'll put that to the message, and the sender name will simply be AI. Okay, so I know it's a little bit small, but you guys get the idea. We have our chat output, LLM, prompt, chat input, name, and chat memory. And now what I can do is click on run here. And when I click on run, you can see that I have a name. So I can enter something like Tim, and I can ask this a question. I can say, hey, how is your day going? Question mark. And when I hit on enter, you can see it shows my name, and then it responds. My day is going well. Thank you for asking. How about yours? Perfect. So we have a basic LLM pipeline set up. Now what we need to do is implement RAG, Retrieval Augmented Generation. So we actually load in the PDF, and then we're able to answer questions based on it. Now, in order to do that, we need to set up a VectorStore database. So let me talk about how that works. All right, so I'm now on the DataStax website where they're talking about their Astra database, which is a NoSQL and vector database specifically for generative AI apps. Now, this is a really fast way to retrieve relevant information when we're building things like Retrieval Augmented Generation pipelines, which is what we're doing. Now, I just want to quickly explain how this works and what a vector database actually is. So when we build this RAG app, what we're trying to do is take a relevant piece of information from all of our context, in this case, it's a PDF document, and inject that into the prompt alongside whatever the user asked. That way, the LLM has relevant data to actually answer the question. However, in order to do that, we need to really quickly be able to retrieve the relevant data, and we need to get the best match we possibly can. So the process goes like this. User types something in, we then go to the vector database, and based on what they typed in, we search for things that are relevant to that. We get that information, we inject that into the prompt, we also pass the user's question, then the LLM gives us some response. But first, we need to, of course, take all of our data, we need to turn it into vectors, and we need to put it into the vector database. So that's what we'll be using DataStax and their Astra database for. This runs on Apache Cassandra, and again, it just provides a really, really quick way to get relevant information and inject that into the prompt. When I start building this out, I'll talk about it more, but for now, go to the link in the description, create a free account, and I'm gonna show you how we can spin up a new database that we can then connect to from Langflow. So once you've made your account and signed in, you should be brought to a page that looks like this. Now what we're going to do is look for this button that says create a database. We're going to click on it, and we're going to go with the serverless vector database, which is exactly what we want for this app. Now you can name this anything that you want, just keep in mind that you can't change it. So I'm just going to call this Langflow _tutorial. And then we can choose our provider. I'm going to go with Google Cloud and in the US East. Now, obviously, if you want to use this in production, you can upgrade your account. But in our case, we just want something simple that we can test with for the video, which is free. Okay, so it's going to make the database. That'll take a few minutes. Once it's done, I'll be right back, and then I'll show you how we get the information that we need to connect to this from Langflow. All right, so now that this is loaded, we're good to go, and we're just going to be looking for the token and then the endpoint here, as well as a collection name, but we can deal with that later. So let's leave this open and let's go back to Langflow and let's start creating this connection. So what we're going to do is we're going to go to the chat input, and then once we have that input, we're going to pass that to a vector search, and that's going to look through our database and find any of those relevant pieces of information and then inject that in the prompt. But before we can do that, we need to build the database with that information. So let's do that down here. I'm going to zoom in a bit, and on the left-hand side here, we're going to go to our vector stores, and we're going to take in AstraDB, which is what we're using. What we're going to do here is we're going to put in the API endpoint, the token, etc. Okay, so we're going to go to DataStax Astra. I'm going to copy in the endpoint, and I'm going to make a new variable for this. So I'm just going to go here and click on variable. Let me actually just delete the ones that I had before, just to make sure we don't get messed up here. Okay, get rid of all of those. And let's make a new one here and call this endpoint. Okay, we'll just make this generic because we don't need to hide that, and then we can save the variable. Okay, so let's put our endpoint here for the API endpoint. Sorry, for some reason that went for our token. Then we need our token, so let's generate the token. Okay, let's copy that, close, go back here, and let's make a new variable for the token, and we're going to call this our Astra underscore token. We're then going to paste the value here, and we're going to make this a credential. Okay, so let's set that as Astra token. And then for the collection name, we're going to make a new variable. Okay, so let's do that here. And we're just going to call this collection. And the value of this is just going to be PDF because we're storing some PDFs. And this will be generic. Okay, so now we'll set that to our collection. So now we have our token, our endpoint, and our collection. What we now need to do is we need to pass some inputs to this, and we need to pass the embeddings. Now the input is going to be the file that we want to load, or the files that we want to load, and the embeddings are going to be how we vectorize this. Okay, so let's first start with the embeddings. The embeddings will be here. So on the side, click on embeddings, and we're going to go to OpenAI embeddings. Now leave this as the default text embeddings, and for the OpenAI key, we can just set this to our OpenAI key new, which is the variable we created. We're going to drag this and connect the embeddings. And now what we're going to do is pass our inputs. So for the inputs, we're going to get a file. So we can just search for one here. This is a generic file loader. So let's load in our file, and we're going to find the file. In my case, it is on my desktop. It's in this folder called Restaurant Q&A. Obviously, you've put yours wherever you've put it, but locate it and then load it in. And then we're going to pass this into our text splitter. So let's find that. This is the split text. Okay, let me give us some more room here. All right, sorry. So what this split text is going to do is it's going to take the file, it's going to split it into a bunch of different chunks. It's then going to pass it to the Astra database, where it will then be converted into vectors. So rather than just passing the entire file at once, we want to split it into small different chunks. Then we pass it to Astra database along with our OpenAI embeddings. And the embeddings is a special model that actually does this kind of search for us, right? So it will convert things into vectors and then allow us to compare the vectors for similarity and get the results back that we want. Now we're going to be using the same embedding model for actually creating the database as well as for searching in the database, which you'll see in a second. So I'm going to take my file and I'm going to pass that as the input here to my split text. We don't need to change any of these settings, but we can if we want to. And then we're going to take this record and we're going to pass that to the inputs to Astra database. So that's it. This will actually now create a new collection in Astra database called PDF or whatever we named it. It will do that by taking in this file, splitting into chunks, passing it here, and then embedding all of them as vectors. Okay, perfect. Now what we're going to do is we're just going to take this embedding and we're just going to make this a little bit easier to view because we're going to use this embeddings up here as well. I know this is difficult to see. I'm going to try to zoom in as much as I can. Okay, so now what we want to do is after we have the chat input, we want to pass that into a vector search where we then go and look for all of the relevant information. So let's move our prompt up here and let's get our vector search. So we're going to have our Astra database search, which is right here. Let's zoom in so we can see this. For the token, this is going to be our variable. So this is going to be the Astra token. For the endpoint, this is going to be our variable endpoint. And for the collection name, it's going to be the collection. That's why we made variables. Now for the input value, that's actually going to be the chat input. So whatever the user typed, that's the input here to our Astra database search. And then the embedding is going to be the one that we had here. So we'll just connect those embeddings, and give me a second. I'm going to clean this up just so it's a little bit easier to see. Okay, so I just cleaned this up a little bit so it's a bit more organized. And now what we're going to do is we're going to take the output from our Astra database search, and we're going to connect that all the way up here to the content for our prompt. So remember, we had the content, the history, and the question. We already had the chat history, and we already had the question. The last thing that we need was the context, and that comes from our database search. Okay, so let's quickly run through this at a high level. First thing we do is we get the name from the user. We then pass that into the chat input, and that's kind of like the name of the person who's sending the message. Then we ask them, hey, type something in. This is their question. Then we connect this to chat memory. The chat memory is just so that we can store what the last, in this case, 5 messages were that the user was typing. And then we pass the chat input into the prompt. Now, as well as that, we pass the history, which is our chat memory, and then we pass the context from our vector search. So our chat input goes to the vector search. We then embed that using the OpenAI embeddings, and we look for any relevant information from our PDF or whatever documents we put in here, and then we get that and we pass that to the prompt. So that's what database search does. It searches inside of this vector database for any relevant information, gives it to us, and then injects it in the prompt, or that's how the prompt works here. Then we take the prompt, we pass that to OpenAI, then OpenAI gives us some output, and we print that out. Meanwhile, over here, we have our file. We load in the file, we split it into a bunch of different chunks. We then take that and we pass that to our Astra database so that we can create this database, and we do that using the same embeddings that we will use for our database search. So now if we want to run this, we can click on run. Let's just erase all of this and let's ask it some kind of question. Hey, can you tell me the hours the store is open? And let's see if this works. So I was just playing with this and it's working properly. One thing to note, you do need to ask it one prompt first that it's not going to give you a good response for, because it just needs to build out that vector store. So before the vector store is built, it's not able to actually give you any valid response because it doesn't have any context. So you're not seeing it on the screen because I cleared it and then did it again. But the first question I asked, it didn't give me a valid answer. Then the second question, it worked because it actually ran this secondary component chain that we had down here, which actually built out that vector store. So last thing I want to show you here is that we can change our name. And when we change our name, what that does is it resets the message history. So I'm now talking as Joey, and I'm going to say, hey, have I asked you anything yet? And you're going to notice here that it's going to say no. And the reason for that is that the last person that was talking to this was Tim, not Joey. So when we change the name, it changes the message history, which allows us to have kind of our own log based on who's asking questions. So it says, no, you haven't asked anything yet. And then we can say, okay, cool. Thanks, whatever, right? And then we'll track this in Joey's message history, whereas Tim's message history will be different. Kind of just an added feature that I wanted to add to this project. So the last thing I really quickly want to mention is that you can import and export these just as JSON. So what I can do is go here, I can change the name obviously, and then I can export this. I can give it a name something like RAG, and then I can download it as JSON. And then if I already have one that I want to import, I can just go back here. I can load it up. So let me just go to my downloads, and I can just take this and just drag it in. And sorry, I need to actually be in the correct thing. So if I drag it here, you can see that when I do that, it just loads it in. So that's as easy as it is to actually load in the JSON and to share it with other people. So what I'm going to do is I'm going to have this JSON, and I'm just going to leave it in the GitHub repository linked in the description. So you can just drag it into Langflow and you can play around with it. There you are, guys. I hope you enjoyed this video. If you did, leave a like, subscribe to the channel, and I will see you in the next one.